Okay, so now we continue with some extra example about solving the polynomial or maybe the cubic or quadratic equation that involve the complex root. All right. Okay, so don't forget like what you learned just now in the previous video. If let's say your polynomial is having all the real coefficient, then your complex root usually will appear in a pair, in a conjugate pair. All right. So it is an important concept that you should remember. Okay. So example 7, they give you two equations here. Okay, so this is equation number 1, equation number 2, and after that they already tell you that u and w are both complex numbers. Okay, right, so they want you to solve the equation for u and w, giving all answers in the form of x plus yi. All right, so you're having two equations here. So in my opinion, I don't think that it is hard for you to solve it. So let's say u minus w equals to 4i. I assume that this is the first equation. So you need to solve simultaneous equation to get both u and w. All right, and after that you're having uw equals to 5, which means that you should know your w is equals to 5 over u. So I will make this as the second equation. All right, so you try to substitute the equation number 2 into the equation number 1. All right, so when you substitute equation number 2 into equation number 1, then you're having u minus 5 over u equals to 4i. And then if you try to rephrase everything, and you will get a quadratic equation. So u squared minus 4iu and then minus 5 equals to 0. So your quadratic equation should be in terms of u. Okay, so you're having u squared and then u power 1 and negative 5. Alright, so once you get this quadratic equation already, then I think you should know how to do it. To get the u, you apply the formula, the quadratic formula that I showed you in the previous video. Okay, so when you try to solve and get the u, you are having two answers for u. Okay, so the u answer is 1 plus 2i. Another answer is negative 1 plus 2i. Again, you will see that it is not in conjugate pair because of the coefficient is not real for this part, right? Okay, so this is your answer for the u. So I hope that you try out on your own and you can get this answer. All right, then if you continue further, they will also want you to get the w, right? Okay, so you substitute the u into this equation. Okay, so your w should have two answers as well. All right, so for the first w, you should have 1 minus 2i. And then for another answer here, it will be negative 1 minus 2i. So this is the answer for w. So in short, this question actually is quite simple, not very complicated yet. So I believe that you can solve it on your own. All right, so this is the final answer here. Okay, then now let us proceed further. Okay, so example 8. Example 8 will be slightly harder. All right, so you can read the question first before we start. Okay, so you can see that this is a cubic equation in terms of x power 3 already, up to x power 3. So for this cubic equation, they tell you that we are having one real root and two complex roots. Okay, so show your working. They want you to verify that the 1 plus I squared root 3 is one of the complex root. Okay, so first, this is the first thing. You need to show that this is a complex root of the equation on top. All right, so every time when you want to verify that a value or a number is a root of the equation, you actually need to substitute it into the equation. And after that, you have to prove that the left-hand side equals to right-hand side. Okay, so I will start from left-hand side first. So my left-hand side is 2x power 3 minus x squared plus 2x plus 12. Okay, and then after that, after you get this one, then you need to substitute the root. So the root is 1 plus I square root 3. Okay, and then you are having the cube root here. Okay, so for me, I just write 3 times so that I can expand it easier. Okay. Okay, my minus x squared. So my x squared is 1 plus I square root 3 multiply with 1 plus I square root 3. Okay, plus 2x. So 2x will be 2. And then 1 plus I square root 3. Then plus 12. Okay. Alright. Then now I will want to try and expand the bracket. So 2 is a 2. I just copy it first. I will expand the first two bracket first. So the first two bracket, I will get 1 plus 2 square root 3i, then minus 3. I already simplify everything lah. Alright, I didn't write it out in detail. Okay, so this is what I have. Then the third bracket remain. Alright, then this one will be the same as this, right? So I'm having 1 okay, 1 minus 3, I straight away simplify become negative 2 lah. So negative 2 plus 2 square root 3i. Okay, then plus 2 plus 2 square root 3i, then plus 12. Okay, then if I continue further, I need to simplify this also, expand this also. Okay, so I rewrite it again. Okay, so I'm having plus 14 plus 2 square root 3i. Okay, so from here, generally you already can see that this and this can be cancelled off already. Okay, alright, then now continue further to expand it. Alright, so I'm having 2 here. Then when I try to expand this one, I'm having negative 2 square root 3i, then plus 2 square root 3i, and then 3 times 2 is 6. So you're having negative 6 here, then plus 16. Okay, then again, before I simplify it, I also can see that this and this one can be cancelled off. So negative 2, negative 6, you have negative 8 inside. Multiply with 2, you have negative 16, then plus 16, which is equals to 0, which is equals to the right hand side. So the right hand side of the equation is 0, right? So that means from here you already proved that this is the root, okay, of the equation shown above. All right. So this is the first part. Okay, so maybe some of you, right? For me, I'm doing a very direct step. That means I substitute the root into the equation straight away. Okay, so some of you maybe have some other method, which is slightly shorter one, also can, you can apply it. All right, as long as you can prove that the left hand side equals to right hand side, or the root is the root given is one of the root in the equation, then okay. All right, so for this method, my one is straightforward, but it might not be the shortest solution. Okay, all right, so you can, of course, you can look for the other one online if you are interested to get a shorter solution, then to prove that this is a root. All right, okay, so I done for the first part. Okay, so this part is done. Then now second part, look at the question again. They want you to state the other complex root. So usually when they ask you to state the other complex root, the very first thing that you need to check is you just double check and see whether everything is real coefficients or not. So 2 is real number, negative 1 is real number, 2 is real number, 12 is also real number. So from here, all these are real coefficient. Therefore, you will know that the other complex root will be the conjugate pair of what they give you here. So one of the root is 1 plus I square root 3. Okay, and since all the coefficients are real, so you can straight away write out another root will be the conjugate pair of the original one. So it will be 1 minus I square root 3. So this is another root that we have. Okay, so the first root is this one, 1 plus I square root 3. So another one will be the conjugate pair of I plus I squared root 3, which is 1 minus I squared root 3. So this is another root. Okay, all right. Then after that, continue to the last part. Then calculate the real root. Okay, so now they want you to find out the real root here. Okay, all right. So to find the real root, generally, again, there are a few different steps that you can apply. Okay, but since in this question, they already give you complex root. You have two complex root here. So now maybe you can do long division if you want. Okay, so how to do the long division? Okay, and how to form the quadratic root? Because you already have two roots here, so you can form a quadratic equation to apply in the long division. Okay, so maybe you can write out like this. I want to get the quadratic factor. Okay, how to form the quadratic factor last time? If let's say you're having x minus alpha and also x minus beta, when you expand it, right, you will realize that it is actually x squared, okay, then minus alpha plus beta x plus alpha beta. So you will see that the alpha plus beta means the sum of root. The alpha multiplied with beta is product of root, right? So to form a quadratic equation. So we are going to do the same thing. X squared minus the sum of root x plus the product of root. Okay, so now what is the sum of root? So you have two complex root here, right? So the sum of root will be 1 plus I square root 3. This is the first root plus the other root is 1 minus I square root 3. Then multiply with x plus product. Product means multiply. So product of the first root with the second root. Okay? Then now you try to simplify and expand this. You have x squared. Alright, then realize that this and this will be cancelled off. Then you can have negative 2x. Then plus, okay, if you expand this, you will realize that you are having 4. Okay, a plus 4. Okay, so this is your quadratic factor. You form the quadratic factor from the two roots given above. And after that, once you have the quadratic factor and you also have the you also have the polynomial already. So to get the real root, what you need to do is you can apply the long division. All right, so maybe for me, I will continue at the bottom. All right, okay. So since I already have the quadratic factor, so to get the real root, I want to apply long division. So the long division will be, what is the equation here? You will get 2x power 3 minus x squared plus 2x plus 12. Then you want to divide it by the quadratic factor x squared minus 2x plus 4. Okay, then you apply the long division, so you should have 2x. So I'm having 2x power 3 here, negative 2x squared. Oh, sorry, negative 4x squared. So this one you involve the knowledge in first chapter lah. All right, so 4 times 2 is 8. All right, then after that you are having 3x squared minus 6x plus 12. Okay, so if you double check, it is plus 3. So 3x squared minus 6x plus 12. All right, So after you complete with the long division, there shouldn't be any remainder because you already know that this is a quadratic factor, right? So there shouldn't have any remainder one. Okay, so to get the real root, you have to use the quotient to find it out lah. So 2x plus 3, you let it equals to 0. So your x is equals to negative 3 over 2. And this is your real root. So that means the answer for the x for this cubic equation got 3 values. The first one is a real root, which is this one, negative 3 over 2. Then the other two is complex root, which is 1 minus I square root 3 and also 1 plus I square root 3. Okay, so you are applying the concept that I mentioned it to you just now here when they ask you to state the other root, okay, for the equation. So they ask you to state only, that means you just use your concept and write out the answer. No need to explain anything. Okay, so you just double check. Okay, as long as the coefficient are all real number, then the other root will be appear in the complex conjugate of one of them, right? Of the one that given in the question. Okay, all right. So this particular question here is slightly longer because after you have two complex root, if you want to apply the long division, so you need to apply you need to find the quadratic factor first. Okay, so the quadratic factor. Again, the formula that we apply, this one you learned it before actually, just that we seldom use it in A level. Alright, so which is x squared minus sum of root x, then plus product of root. So I think this is important. Okay, bear this in mind, remember this in your mind so that you can apply anytime when you need it. Alright. Okay, so example 8 will be slightly longer. Alright, and then there are something that we didn't use it very often. So I hope that you have this in your mind, in your mind so that you can apply anytime even you need. Okay, then now let's continue to example 9. Okay, so if we have a look for example 9, I think it is quite similar, okay, with like what we learned just now. Okay, so they already tell you that this is one of the root of this equation. Okay, so they want you to show the working, find the value of A, and write down the other complex root. Okay, so since they already give you one root for this equation already, okay, so which means if you substitute the root into the equation, you will be able to find out the A straight away, right? Okay, so I'm having negative 1 plus I square root 5 power 3 plus 2z. So 2 negative 1 plus I square root 5, then plus A equals to 0. Okay, so please spend some time to expand this. And then after that, you move all the thing to the right hand side. You keep the A on the left. Eventually, you will get the A, which is equals to negative 12. Alright, so I'm not going to show you the detail for this question. You try it on your own. So your A is negative 12. And after that, when they ask you to state another root, so what is the answer for another root? So very easy. When they ask you this kind of question, you always double check your coefficient. So this is 1, which is real. This is 2, also real coefficient. Negative 12 is also a real coefficient. Therefore, the other root will be the conjugate pair of the original first root given. Okay, so the other root will be negative 1 minus square root 5i. So this one is very straightforward one. You just write out the answer. There's no special step, no special explanation and anything. All right, just write out the answer. Okay, so this is how we try to solve all the polynomial that now we bring in the concept of complex root. Okay, so in exam, there are quite a number of questions from this part. Some of them is quite challenging, so make sure you try as many type of questions as possible from past year. Alright, so I will stop here for this video. Then in the next video, we are going to discuss about the argument and also the modulus, okay, of a complex number.